Hi, this is Alex from devstories.eu, Kubernetes and Helm Fundamentals, Episode 6 of 10. You want to deploy a single application, but you end up managing hundreds of lines of static YAML across deployments, services, and ingresses. When you need to push that same application to a staging environment, you copy those files into a new directory and manually find and replace image tags and host names. It is fragile, highly repetitive, and impossible to maintain as your infrastructure grows. This is the exact problem Helm exists to solve. Helm is the package manager for Kubernetes. You can think of it like apt, yum, or homebrew, but designed specifically for Kubernetes resources. Instead of treating your application as a loose collection of independent YAML manifests, Helm bundles them together into a single cohesive unit. This packaging format is called a chart. A chart is essentially a directory containing files that describe a related set of Kubernetes resources. It holds all the definitions your application needs to run. The primary mechanism that makes a chart useful is templating. Raw Kubernetes manifests are entirely static. A Helm chart, by contrast, replaces hard-coded infrastructure details with template variables. Instead of writing a specific replica count, a fixed container image tag, or a distinct environment variable directly into a deployment file, you define placeholders. When it is time to deploy, Helm merges these templates with a separate file containing your specific values. This architecture means you only ever maintain one single chart for your application. You simply pass it different configuration parameters depending on whether you are deploying locally, to staging, or into production. When you take a chart, combine it with your specific configuration values, and deploy it to a Kubernetes cluster, you create what Helm calls a release. This is where it gets interesting. A chart is just the generic blueprint. A release is the actual deployed instance running in your cluster. Because of this strict separation between the blueprint and the instance, you can install the exact same chart multiple times into the exact same cluster. If you need 3 separate instances of a caching server, you do not duplicate the YAML. You install the caching chart 3 times. Helm tracks each installation as a distinct release, with its own unique name, its own configuration values, and its own isolated lifecycle. Helm also tracks the state and history of these releases inside the cluster. When you update an application by providing a new image tag or modifying a setting, Helm evaluates the differences and creates a new revision of that specific release. It applies only the necessary changes to the underlying Kubernetes resources. If an update fails or an application starts behaving erratically, you command Helm to roll back to a previous revision. Helm knows exactly which Kubernetes resources belong to which version of your application, handling the creation, modification, and deletion of those resources as a single operation. The core shift with Helm is abstraction. You stop managing independent text files representing disconnected pods, services, and volumes, and you start deploying, configuring, and upgrading complete applications. Thanks for listening. Happy coding, everyone.